Welcome back to the Roamin channel, fellow Earthlings. Today, let's talk about hydrology and the weather at the same time because they're interconnected. So, here's the current national radar. Actually, it's about a half hour or so ago. We are currently right up here in northern Illinois, in northern Kane County. And you can see that there's a line of stratiform rain coming our way while there's a cold front down here. And the center of the low right around the Kansas and Oklahoma border. So if we look at the water vapor imagery, we can see the system moving from the east. Oh, yeah, wait for it to restart here for a second. You can see the system moving from the west. And then as moisture comes up from the Gulf, rain develops and moves through the area. And then you can see right at the end, the center of the low right above the Kansas-Oklahoma border, right there. So, another view of that is if you look at the LowLevel Jet this is the 800 millibar height wind speeds, which is about like 5,000 feet above the surface. You can see a strong low-level jet blasting forward from the Gulf of Mexico, bringing up moisture up into the area, as you can tell by the brighter colors here. Also by the cursor, you can see how it's faster. So, then also on top of that, you have the fronts right here. So you have a warm front here and a cold front here. If I'm not mistaken. Yeah, that should be right. But so basically the way the front works is as warm air moves in from the south, also as cold air moves in from the north, you get because warm air is less dense than cool air, it's going to rise above, and because there's also moisture in there, it's going to rise, the water vapor is going to cool and condense, and it's going to fall out of the air as rain, as you can see in this diagram. So, and you get a rain precipitation area looking like this, and we're right up in this area. So we didn't get as much as other people, but we got a bit of rain. So looking at the CoCoRaHS data, if we zoom in on our area, we see that we have roughly 1.36 inches of rain in our area, but down to our south we have more than an inch more in southern Kane County. So here are the river gauges in our area. We got one right. This is actually right where we are. We're gonna go look at this gauge in a little bit, but down in the south you can see that there's some flooding occurring. So if we look at our gauge in Algonquin, Illinois, you can see how we're below the action height. And it's forecasted to rise up. That's because we're expected to get some more rain this evening. And, rain, the action stage occurs at 9 feet, And that means at 9.3 feet, flooding of low-lying yards and Holiday Hills, some yards flooding in the Valley Hills on Grove Street. Water approaches outbuildings in the Cary Long River, and so you'll be able to see what that means in a short bit when we walk out there. And this is the one to our south. You can see it's already in a minor flood stage, which means it's minor flood stage. They're at 13 feet, so they are below. They're at the low-lying flooding begins near the river. And we're currently here at our current stage is, where's that at? There we go. Current stage is at 8.41 feet. So, also another interesting cool thing is that about last April, this cool new thing started coming out. So instead of having point forecasts like this in just different areas, they started modeling the entire river system in the United States. So this is just an example. It's out of the new Water Prediction Center from NOAA. So if I was to say click here, so we have the gauge up here and the gauge down here, but we don't have any information in between. But through mathematics, we're able to model that, as you can see here. So here's what was analyzed, what actually was seen, and here's a model of going out. So an area like here, so we have the long term and the medium term. So you'll see it just, so here's going to be the rain that's going to happen tonight, but you can see the long range and the medium range models are in disagreement of what's going to happen there. And that's expected, because long range models tend to don't handle precipitation like and detail that off that well as you would need for this kind of model. So I would trust the medium range much more than I would trust the long range. And for more information about this, actually no, not for more information. From this, we can get more detailed. We can see how water flows through time down the stream. So you can actually see, if you watch carefully, you can see individual rainstorms forming. Let's see if we can wait till one happens. You can watch them happen and then watch the actual stream flow down the stream. Here, I'll put up a scale here so we can actually see what we can see. Yeah, come back. So here, wait for this to restart. Or you can see right here, I can see how this has gone down the Illinois River. But you can definitely see it. Here we go. From the storms that are happening right now, you can see all the streams surge and all the tertiary surge, and then start flowing downstream to the Missouri River, to the Illinois River, to the Mississippi, and then eventually out to the Gulf. I'll let you watch this for a little bit. This is exactly what I've been wanting for years, and finally we were starting to actually produce it. It's a hydrologic model called this is the National Water Model, if I'm not mistaken on the name. And yeah, so we're up here, and you can see how it's surging up here, and it starts to just flow down. So as we all know, water flows downhill to the lowest point, and getting down towards the Gulf eventually, and out to the oceans. So if you want more information on this, I'll link this webpage in the description, as well as the location of everything else. Is the National Water Model. There's quite a bit of information about it. So we went from all these different point forecasts of 3,600 points to over 7.1 million. It's using all these. Then here's a breakdown of how each individual model detail works. So analysis is obviously the most accurate. Short range, little less accurate, and a little less accurate as you get out in the long distance. And for each meteorological forcing model that's put into each of them. And you can actually download the output off this directly from NOAA and use it in your own data, which you can get actually off here or off of an FTP right here at this site. So with that, let's go out and look at one of these points and where these points are found and how we're actually able to observe this. So let's leave the virtual world and enter the physical world. Woo! hopefully that work. Hopefully that ended up working in editing. So once I see that my recording has stopped on my laptop, let's get out. So let's go. So we're here, Algonquin, Illinois. A storage facility, obviously, right there. A nice little neighborhood that we're just talking about in that model, or in the point forecast. So let's head up here onto this trail. Here you have a forested area in northern Illinois. On this trail, I think it's the Fox River Trail, it doesn't flow, it runs for quite a long distance. I think it goes all the way down to Aurora, or possibly further south to the other, to the other river gauge. There's a river gauge right up here on the second bridge. Another interesting thing is that I believe this used to be a rail line. The only reason I say that is because this first bridge, is awfully over-engineered for just bicycles and people walking. Like, by a lot. Look at it. Look at those trusses. It's not a truss, but you know what I mean. It's quite over-engineered. So, reuse, recycle, and reuse bridges. Oh yeah. Well, here's one of those yards that was discussed in the flooding characteristics of the area. So, it'll start raining now. Here we have it. Here's a river gauge in person. The box, at least, where all the fun computing and actual analysis is done. Hopefully you can hear me. You got some solar cells down there, and kind of where it actually broadcasts it to the National Weather Service office. And here is a pipe. This pipe is filled with air, or a gas that goes around here, through here, and up and down into here, and from here it goes down into the river. So basically, as the water level rises, the gas in the pipe is under more pressure, and the box over there senses the increase in pressure and knows that there is a higher water level. And that's the simple physics of how we're able to measure river heights remotely. And look, there's some cute little duckies down there. Hey duckies, hello. Anyways, so you can tell that the water here is a little bit higher than you would expect, judging by those trees over there, and just by the coastline. Just looks a little high. But yeah, you can tell that these yards will flood when it gets up another foot, it would be. less than a half a foot to actually flood these yards. About a foot to actually when these yards flood. These would flood after these yards, just judging by looking at it. So these would be the first to flood, followed by these yards, and then finally these yards. And that's all measured by this. Oh, and by the way, I never mentioned it. This is the Fox River. I didn't mention that earlier. That's pretty cool looking. Split in the flow right before it gets to the bridge to cut on erosion of the pylon. Let's walk back over here to the river gauge. I just think these things are the coolest things. And just these boxes that just sit out here and just take in information and give it to us so we can produce models and model the rivers. And I even got a nice little board here. Well, go ahead and pause it here if you would like to read this, but I'm going to leave it here. Thanks for tuning in to the Roamin channel, and remember, if you liked this video, don't forget to like it, and don't forget to subscribe if you want to see more of this. Roamin, signing out.